Do you struggle with phylogenies? Does the thought of seeing one of these and needing to interpret it fill you with existential dread and a desire to run away into the wilderness? Well, you're not alone. Today's video is going to cover how to read phylogenies, common mistakes that we see with interpretation, and at the end I will give you 5 exercises to test your newfound phylogenetic knowledge. So, as always, use the chapters down below to skip around to where you need to be, and look at the links in the description for further information. And also, yeah, subscribe if you like what you see. Do all the things that YouTubers tell you to do. So let's just hop right into it. So this is a real phylogeny. This is actually the phylogeny that I'm using for my master's research, and it's for the world's turtles. We are not going to be looking at this for the most part, so don't worry. This is 340 species. It's a little bit much. But a phylogeny, all it does is it tells us the relationships between organisms. Let's look at a more simple example here. So this is a phylogeny of 4 species, species A, B, C, and D. And what this phylogeny can tell us is, well, how are A and B related to one another? How are A and C related to one another? How are A and D related to one another? And all the different combinations thereof. A phylogeny is largely made up of 3 components. We have our tips, we have our branches, and we have nodes. So tips are by far the easiest thing for us to see. The tips are what's at the top of the phylogeny, right? So in here, the tips are A, B, C, and D. They are the taxa that we are looking at. Tips could also be, depending, in this case we're using species, but tips could be populations. They could be entire families of organisms. Really, it's just what's at the top of the phylogeny, okay? Coming down from each of the tips are our branches. There should be an E here. I'm just going to add that there. Branches. And so the branches are these parts. They are in this reconstruction, the vertical components between the tip and this right here, which will be the node, which we'll discuss in just a second. Now, branches do communicate information. In this type of scenario, this is a time calibrated, so it's telling us the amount of time that goes from the top of the branch to the bottom of the branch. This here might be 150 million years ago, right, for example. But they can also tell us the amount of genetic changes over time, so the amount of different mutations that this organism, this taxa, has accumulated since this point in time. Now the nodes are those branching off points. So when we speak about phylogenies, they are trees. They're not ladders. They are bifurcating, meaning they split into 2 at various points. Those points are the nodes. So again, the nodes are going to be right here. And these represent the most recent common ancestor. Okay, so we're going to put this as just common ancestor. And these are the 3 main components of a phylogeny, okay? We have our tips, we have our branches, and we have our nodes. But now let's introduce a few more terms that you will often see, and I've already mentioned a few of them. So one of them is a common ancestor. So whenever we're looking at a phylogeny, again, we look at these nodes to see what is a common ancestor. And usually we're looking for the most recent common ancestor. And so what we do is we pick 2 taxa, 2 tips on the tree, and we follow their branches down until we can find the point where they intersect at a node. Let me give you an example. The easiest one here, let's actually zoom back in on, oopsies. Let's actually zoom back in on this tree. Let's make it a little bit bigger. So let's say we want to find the most recent common ancestor for A and B. Okay, do what I just said. Take your fingers and go down the phylogeny and find the node where they first intersect, okay? So in this case, this is a very easy example. I'm going to do it with this highlighter here. So let's go down to A, and let's go down to the first node that we run into. Boom, we ran into this node here. Okay, now let's do the same thing with B. We start at the tip B, we go all the way down, and we run into the first node we see. Boom. This node right here This is the common ancestor, the most recent common ancestor, to A and B. And we'll denote that with MRCA, most recent common ancestor. But of course, this is a very simple example. So let's do this with A and D, okay? I'm going to remove some of my marks here to make this a little bit more clear. In fact, let's remove all this red as well. Okay, So again, we're gonna look at the most recent common ancestor for A and D. And we're gonna use this highlighter again. So what I'm going to do is I'm gonna start at A, and I'm gonna go down until I hit the first node that I run into, which again, is the same node we had last time. Okay, I'm gonna do the same with D. I'm gonna go all the way down and run to the first node that I run into, which is all the way down here. Now this is where it gets tricky. So there is nowhere left on this phylogeny to go from D. I can't go down here. This is called the root of the phylogeny. So this is just kind of what holds it all together. This is the point that is the oldest part of the phylogeny. So because I can't go anywhere further, I'm gonna stop. I'm gonna stop at D, okay? And I'm gonna go with A. I'm gonna keep on going. I'm gonna go down to another node. Boom. Okay, well, I still have not met up with D. Now, if you'll notice, I never go up the phylogeny. I never go up. Okay, I only go down. So I would never go up to B or up to C. I would never do that. You always work your way down the phylogeny, going backwards in time. And so, again, we're here. We need to move down again. Let's go down. And now we have met up with D. So right here is our most recent common ancestor of A and D. And that's all you really need to do. So this does take a little bit of time to figure out, and it can be very, very confusing. And of course, we can do this in the reverse hand. This is our most recent common ancestor, so we could then ask, what are the descendants of a node? So let's again remove some marks, and let's ask ourselves, what are the descendants of this node right here? So you'd work your way backwards. Go from the node, and then work your way up the phylogeny, and find all of the tips. We'll use that highlighter again, and so from here, let's work our way up. And we have C is a descendant of this node here. But let's work the other way, right? So now we can go this way up the phylogeny, we hit another node, let's go down one path first, I'll go down to the right, and we run into tip number B, or tip B, not really a number. But we have another path to do. We can go here, we can go up, and then now we're here at A. So what we can say from here is that the descendants of this node down here are A, B, and C. That's it. We just work our way up the phylogeny. Eventually you get very good at this and you can just see the node, see the descendants, and you'll know. So I want to talk about one more grouping, and that is sister species or sister groups. So let's say we have this taxa here, A. And I ask yourself, what is sister to A? This is a really common terminology you'll hear. And what sister means is it is the group that is on the other side of that bifurcation that we talked about. It's on the other side of the split, okay? So we know that A splits down here, right? This is the most recent common ancestor to just A, this node down here. And it splits going up to B. So B is the sister group to A. Now, let's ask this again, but on the other side. What is D? What is sister to D? Okay, so again, go down to the most recent common ancestor of just D, just to make this, we'll use the highlighter again. We'll go down, we hit that first node. This is our most recent common ancestor of just the taxa D. In prior ones we looked at with two species, but for one taxa, you just go down and you just choose the node that you first run into. So then the question is, what is sister to D? And this is where it gets a little bit confusing, right? Because we go up the phylogeny, just like we did from that node, we go up, then we hit this node. Well, where do we go now? What is sister to this? Well, the correct answer is all of the descendants from this node. All of the descendants from this node. And we just figured out what the descendants were. So here, the sister group is the group that contains A, B, and C. This is actually what we call a clade. And we'll talk about that just a little bit more later on, but this is the clade containing A, B, and C, and it is sister to the tip D. We now have all the necessary components to understand and read a phylogeny. But there are 3 patterns that are so common in evolutionary studies that we need to talk about them. We have monophyletic, paraphyletic, and polyphyletic. And I know this really throws off students who are just learning phylogenetics. So let's try to break them down very simply here. And let's just keep using this exact same phylogeny. Okay, so let's remove all these other marks. So, monophyletic, we'll start off with that. So, monophyletic. This is a grouping that contains a common ancestor and all of its descendants. That's all monophyletic is. Okay? Again, the common ancestor and all of its descendants. And we've already done this. So again, what is the monophyletic grouping that is coming from this node? What monophyletic group can we make from this node? Well, if we make this node the most recent common ancestor, right, that we just said, and we know that monophyletic groupings include all of the descendants, well then the monophyletic grouping is that node plus all of the descendants, A, B, and C. That's it. That's all monophyletic grouping is. It is the easiest one, but it is also the most important one for phylogenetic studies. So, let's keep going. Now let's look at paraphyletic, because this is the one that kind of starts to throw off people. So, paraphyletic is the common ancestor, but not all of the descendants. Okay, I want to say that again. Paraphyletic groupings have a common ancestor, but not all of the descendants. They are excluding a descendant. So, let's say we want to make a paraphyletic grouping based off of this node right here, okay? Let's say we want to do it down here. We're going to assume this is the most recent common ancestor that we are interested in. What paraphyletic groupings can we make? And there's actually a few we can make from here. So what I'm going to do is I'm just going to make one. Let's say we have a most recent common ancestor and we just do C and D, okay? So let's draw a circle around that. We're going to make sure to include the node because that's still the information within this grouping. And we're going to go all the way up. So this is paraphyletic because while it does include this ancestor down here and the taxa C and D, it is excluding the descendants A and B. Because from this node, the descendants are A, B, C, and D, all of them. But we are only accounting for C and D. This is paraphyletic groupings, okay? And paraphyly, that's another way of describing this pattern, monophyly, paraphyly, and then polyphyly, which we'll talk about in a second. Paraphyly typically means that we have an improper grouping of some type. Usually this is because of a mismatch between taxonomy and phylogeny. And the last group we're going to talk about are polyphyletic groupings, okay? And polyphyletic groupings are a pattern that we do see on phylogenies, but they are typically not as informative. So simply put, a polyphyletic grouping is a collection of multiple tips, multiple descendants, but no real grouping of that common ancestor, okay? So a great example here would be B and C. We can say they are polyphyletic. So this is just 2 tips. We're not including that common ancestor. And typically, you see polyphyletic groupings when you're talking about convergent evolution. If you circle birds and bats on a phylogeny because they both have wings, that would be a polyphyletic grouping because it's ignoring all of the other mammals as well as all of the other reptiles, which we'll talk about in a second because birds are reptiles. So let's give you an example using the concept that birds are reptiles and why that is. So, originally, when we used to make the phylogenetic relationships of organisms, right? So we know that snakes, lizards, and crocodiles, we know they're reptiles, right? And we used to believe that their groupings, their phylogenetic relationships, looked something like this, okay? And let's also make a relationship with birds, okay? So this used to be the relationship. Now, again, this is a good time to also introduce clades, because again, clades are groupings of tips. Okay, they are groupings that we can typically assign a label to. So based on this, we could say that this group here is the clade of reptiles, right? So let's write this, clade equals reptiles. And remember, this is the old grouping, okay? And then we could also say this is the clade of birds. Now, the thing with clades is that they need to have these, they need to be a monophyletic grouping here. And in this case, we can see that it is here. We have this most recent common ancestor. We have all of the descendants. So therefore, these reptiles are a good monophyletic clade. That's fine. You can have paraphyletic clades and polyphyletic clades, but I prefer to, usually a clade is monophyletic. And I just realized that I am covering up this description. Let me move that down here. In this scenario here, this is still accurate. So you might be wondering, why is this considered a clade, even though down here, this is the most recent common ancestor, but it's not represented. It's technically here. You could be very correct in saying that this is a paraphyletic clade. That is totally fine. But the assumption is that this tree has been collapsed down, and there are many more tips that we're not seeing. So here it might branch off into this. Say hummingbirds are over here, hawks are over here. So that's the example therein. But this is a clade of birds. But we mentioned this grouping is not correct. Okay, this is the very old way of looking at these groups. So let's erase everything again and then redraw our current knowledge, okay, of these relationships. Okay, let's get rid of all of this. So what we actually found is that birds and crocodilians, so alligators, crocodiles, caimans, that type of stuff, are actually more closely related to one another than they are with the reptiles, with those lizards and the snakes, the squamates. So these are still closely related to one another, but these groupings are what we now know to be true. Well, we know that crocodilians are reptiles. We are pretty sure of that. We would call them reptiles. But this introduces a problem. So now we have the group that is a reptiles. Okay. Traditionally, we call them the reptiles. This is paraphyletic. Okay. So this is paraphyletic. Why? Because it contains this common ancestor, but not all of the descendants. Because it is excluding the birds. So to make this a monophyletic group, which is a proper grouping of organisms, this is how we should be defining clades and groups of organisms, we need to take that common ancestor and all of the descendants. So that would be the birds as well. And this is monophyletic. Now, you could make the case that, yes, the name doesn't really matter. Reptiles is maybe outdated. We could easily say that, okay, reptiles are birds, right? That could have been the conclusion at the end of this, but we just use reptiles because it's a little bit more, I think it is easier in the taxonomic sense, right? Instead of reclassifying gators, all the lizards, all the snakes into birds, it's easier to just recategorize the birds into the reptiles based on crazy morphological differences. I'm already expecting the birders in the chat to be, yes, call the snakes the birds, right? You do you. Drive the algorithm going for me. But this is a great example of showing off, monophyletic groupings and paraphyletic groupings, and why reptiles, or why birds are reptiles. Phylogenies are all about relationships to one another. They are about relationships between the tips, okay? And there are some very common mistakes when reading phylogenies. So at the nodes, this is a concept that is a little confusing at first. So at all of our nodes, we have 3 nodes here. All of these nodes can rotate. Okay. They can rotate and keep this same information. So let's give an example here. So we have the snakes, we have the lizards, we have the crocodilians, we have the birds. Okay, here, using the information we've already discussed, we know that the snakes and the lizards are closely related to one another. They are closely related, right? Because their node is right here. So we would say that the snakes are more closely related to the lizards than they are to the crocodiles, right? Because their most recent common ancestor is shared at an earlier or a later point in time, okay? And the crocodilians are more closely related to the birds because they share a most recent common ancestor that is not shared with the lizards and the snakes. We would also say that the clade containing the lizards and the snakes, so that is this clade right here, is sister to the clade containing crocodilians and birds, right? Why? Because they share this common ancestor. Okay, so that's just the basic information I want to share. That snakes are related to lizards, crocodilians are related to birds, and that crocodilians and birds are closely related to snakes and lizards. Those are the three groupings that we are going to work with. Now, again, we can rotate around the nodes. And we're going to do this, hopefully this makes sense. If we rotated this node here, right? You rotated it 180 degrees, what would you see? Well, you would see the birds over here and the, oopsies, here we go, and the crocodiles over here, right? So you just see that grouping. You'd see them just swap 180 degrees. Okay, now then, let's write out those conclusions that we had earlier, okay? So we have snakes. Oops, let me move back to the top. Apologies for this. So what are our conclusions, right? We know that the snakes are closely related to the lizards, okay? So snakes related lizards. We know birds are related to the crocs. And we know that the snakes plus lizards are related, most closely related to birds plus crocs, okay? These are the conditions that we are trying to evaluate if they are still true when we rotate. Well, we've already rotated birds and crocs, right? So do all of these statements still hold true? Well, the snakes are still related to, most closely related to the lizards. We haven't changed them at all. So, awesome. We know, let me choose a green check mark. We know that the birds are most closely related to the crocs. Now, is that still true? Because again, we've switched the placement, we've rotated around the node, the placement of the birds and the crocs. Well, the birds, their most recent common ancestor, is this node that is shared with the crocs. So, this statement is still true. And then that last one, are the snakes and lizards still most closely related to the birds and the crocs? Well, looking at the nodes, yes. Cool. So if we do another rotation, let's do a big rotation this time, okay? So we could just, let's do 2 rotations. So what we're going to do is we're going to rotate, sorry, I'm still getting used to this software. We are going to rotate the lizard with the snake. Now again, it looks like I'm just switching tips here, but you got to imagine that around this node, we are rotating 180 degrees. Kind of like those old baby toys that you hang from the ceiling and it spins it around and it has little frogs and salamanders on it. I don't think there exists one with frogs and salamanders. It's usually stars, but we should make that. But let's do another big rotation, okay? Let's say we want to rotate around this node here, okay? So this is a big rotation. Now, it's going to be a little messy. So what I'm going to do is I'm just going to rotate these 2 clades. Again, the reptiles, the snakes and the lizards, and the birds and the crocs. We're going to rotate around that axis, okay? And all I'm going to do is you need to make sure that at these nodes, at the nodes lower down, these are not rotating, okay? These are not rotating, just this node down here. So what you're going to see is you're going to see the birds and the crocs coming over to here, and you're going to see the lizards and the snakes over here. Okay, this is a big rotation, okay? But just because it's rotated And now that the order of the organisms looks out of place, how do these three relationships stack up? Are the snakes still most closely related to the lizards? Well, looking at this, they go to this common ancestor, this common ancestor. That is true. Are the birds still most closely related to the crocodiles? Well, the birds go to this common ancestor, the crocs go to this common ancestor. That is true. And then, are the snakes and the lizards still most closely related to the birds and the crocs, or the clades containing those groups? Well, we start at this one, because this is the clade that contains snakes and lizards. We go down to this common ancestor, and then from here, the birds to the crocs, this common ancestor. So this information still held true. And these relationships still hold true even if we do massive rotations around the phylogeny. So this is a very, very important concept to understand, is that rotations along the phylogeny do not change the underlying information. And this is an important concept to understand when it comes to some very common ways of misinterpreting phylogenies. So another way to draw a phylogeny is this way. So this is a much easier phylogeny to draw because you can represent many, many points here. And here, this phylogeny is the exact same as this phylogeny, okay? Like exactly the same. These are equivalent. I'll draw an equal sign here. So if you have a node, let's label this A, B, C, D, and D. Cool, right? Because here are the nodes, here are the tips, and these are the branches, right? So all the information is still contained within. This is just a little bit easier to draw. And you can still rotate around nodes on this tree. So this is a very commonly misinterpreted reconstruction. And the question would be, okay, which of these organisms is the most advanced? Which is the most evolved of the organisms? In many cases, people will say A, because it's at the end of this, okay? And this goes back to some very old school evolutionary thinking that evolution is a progression, but it's not that. Again, evolution is about breaking it up into different components. It splits. Here, we did not have the crocodiles evolving into birds and then the lizards evolving into snakes. Rather, we had a common ancestor to these groups that then gave rise. You could say that this common ancestor of lizards and snakes was some type of reptile that looked similar to reptiles, to lizards and snakes, and then ultimately diverged into the two groups, right? And so here, again, even though it's in this format, this like ladderized almost format, it is still a tree. It is still breaking off into two separate components, okay? Again, this is the exact same thing here. Meaning, what this means is that we can switch all of these tips around. So there, I just did a 180-degree rotation of A and B. On this tree here, that is the same as doing this, which we've already covered. Again, rotations around the node do not change the information. So let's do it with a rotation around this node here. Now it's going to be a little bit more tricky on this phylogeny, but let's say here, let's use this phylogeny since that's the one we've introduced. Let's say we want to rotate around this node here, okay? What would that look like? Well, we'd still have D over here. So let's just draw D so you're not worrying about it. And then, since we're rotating 180 degrees, we're going to have the split for A and B. We're going to have the clade A and B on this side. And we're going to have C on this side. Okay? These are the same trees. These say the exact same information. This is a rotation around the node. And if we want to draw the other phylogeny, this type of phylogeny here, this would simply look like this. It gets a little bit messier. So we always draw this backbone. We have C up here, and then we have the group containing A and B right here, and then we have D right here. So what I'm trying to get at, again, we've already covered rotations. I'm not going to go too in depth. Just know that these two phylogenies are the exact same. They say the exact same information, but it's a mistake to assume that whatever is on the most right side of the phylogeny or on the most left side of the phylogeny, if you draw this inverted, is the most advanced. That's not true because of this rotation concept, right? Because look, we've demonstrated now that the taxa, the group, whatever, on the most right-hand side of the tree could be A, B, or C, and we could even draw it with D if we wanted to. So again, this concept of most advanced, most evolved isn't really a thing. And you'll often see humans at this right side of the phylogeny. But we could draw this if D was bacteria and A was over here being humans. We could draw it so that bacteria could be the most advanced over here, right? We could just keep rotating it until that happens without changing any information. So that's what I really wanted to show. But so far, we've covered tips, branches, nodes, common ancestors, descendants, sisters, monophyletic, paraphyletic, polyphyletic, rotations, and common misinterpretations of the phylogeny. So I'm going to give you 5 exercises that you can do to test your knowledge, and all the information needed is in this video. So let's start off with number 1. This will be our first problem. And here there are 3 phylogenetic trees with red circles indicating groupings. There is 1 monophyletic group, 1 paraphyletic group, and 1 polyphyletic group. And the phylogenies are numbered 1, 2, and 3. Pause the video now. I'll give you 30 seconds to do so. And tell me which of the trees is monophyletic, paraphyletic, and polyphyletic, right? Which one of each of those trees? There's only one of each. So pause the video now. Give you a little bit of time. But the answers here, let's break down. Let's actually classify what this first tree is, okay? So, we have a grouping that surrounds D, E, and F, and includes this node right here. So, our first test should be, does this include a common ancestor and all of its descendants? Well, we know that it has a common ancestor here. This is the only common ancestor that is fully representative of everything in this grouping. And does it include all of the descendants? D, E, F. That is true. So number 1 is monophyletic. Okay. Cool. Let's go on to number 2. Now, we go down here. We try to find the most recent common ancestor to this group, C, D, E, and F, right? Let's do this a little more explicitly this time. So we'll go down the tree. We'll go down to F. We'll stop at this node. We'll start with D and E. D goes down to there, E goes down to there. They still haven't joined up with F, so we're going to keep going down the tree. We hit a node here. Let's stop for a second. Let's now work with C. C, we go down to the most recent node. We see it's not joined up with the clade C, D, and F, so we go down until the next node. Let's now work on this clade that comes down from D, E, F. We go down 1, we meet up at this node. Boom, cool. We just found the most recent common ancestor for C, D, E, and F. Now, from this node, from this most recent common ancestor, do we have all of the descendants? The answer is no. We are excluding A and B, because if we follow this node up the tree, oops, I pressed a button, we see that A and B would have been included if we were being monophyletic. So in this case, this is paraphyletic. Made it a little easy, I guess. I just did it 1, 2, 3. Now let's go to the last one. You could do this, of course, just by process of elimination. We know this is the polyphyletic group. But why is that? That's because if we circle this grouping, we can find a common ancestor to D and E in this grouping, right? We do have it here. But C would not be represented there. We technically would be circling this entire branch leading to this node for C, but this has no real common ancestor and multiple descendants. It's a little bit all over the place. Again, this would be a great example of maybe convergent evolution if this is how you were drawing the grouping. But yeah, this is a polyphyletic grouping. I will say in phylogenetics, most of the time you deal with monophyletic and paraphyletic groupings. Polyphyletic groupings are nowhere near as common. So if you just know monophyly and paraphyly, you can always be like, well, if it's neither of those, then it's polyphyletic. That's usually a good rule of thumb. So let's go on to the next problem. All right, problem number 2. And the question is relatively straightforward. There are 3 phylogenies shown on the screen. Are they all the same? Do they all contain the same information? Do they tell you the same story, right? So I'm going to give you a little bit of time to pause. And now we will answer the question. The question here is, yes, all of these phylogenies are actually the same. And again, this goes down to that rotation principle, okay? So we'll do a big yes with an exclamation point because we're excited. And with any of these problems, don't feel bad if you got them wrong. We learn when we make mistakes. So I always encourage people to make as many mistakes as possible because that's how you learn as fast as possible. So let's look at this first phylogeny, right? Again, we're going to look at those groupings of organisms. So here is A related to B. So what we're going to do is we're going to draw them out like this. So A and B. So we know these are a relationship, okay? We're just going to put this here. Then we're going to have C and D are related to one another because they have a common ancestor here. So these are all of the relationships. We're just going to write out every single relationship of this phylogeny. We know that C and D are related to E, so we're going to draw it like this. So C and D is related to E, okay? This is actually notation you will learn eventually. And we know that A and B, this group, is most closely related to the group containing C, D, and E. So we'll draw that down here. A, B, C, D. Okay, C, D. So these are the relationships that we would expect to see in the other phylogenies if they were the same, okay? A being related to B, C being closely related to D, the clade containing C and D being most closely related to E, and the clade containing A and B, oopsies, being most closely related, we forgot one, we have a paraphyletic grouping here, A and B being most closely related to the clade containing C, D, and E, okay? So, we're always going to list these out in alphabetical order when we draw these relationships, regardless of their position on the phylogeny. So, what that means is for this first one, okay, we look here, A and B. Cool, right? Like, it could be B and A, but we're going to write it at A and B to make it a little bit more easy. Cool. Here, we have this next grouping right over here. So we have C, D. Okay. What is this clade mostly related to? E. So C, D, E. Again, we're putting this in alphabetical order in terms of the relationships. DC with E would mean exactly the same thing. No difference, but we're just drawing it here. And then lastly, these groups, so AB, is most closely related to the clade containing CDE. Okay, awesome. So from this, A and B is equal, CD is equal, CDE is equal, ABCDE is equal. Awesome. This third one is a little bit more complicated. There's a lot of rotations here, but if you went through it step by step, you could figure this out yourself. So let's start with this relationship between A and B, okay? I want to start over here. So in this case, it's over here, okay? So A is most closely related to B. We're going to draw that out the same. Let's look for this CD grouping. Is it found in this phylogeny? Well, yeah, it's found right here, right? Cool. We can write CD. Now, what about this clade containing CD and E? CD being the clade that is most closely related to E. Well, that is found right here, right? So even though it's rotated, yes, we could write E, CD, right? That we could write that, but that is equivalent to writing C, D, and E, okay? And then finally, this last clade is the clade AB most closely related to CDE. Well, of course, we look across the whole phylogeny for this one, and we see that AB is indeed most closely related to the clade containing CDE because of this common ancestor right down here. CDE. So even though these phylogenies have been rotated like crazy, they all contain the same information. In all three of these phylogenies, A is most closely related to B, C is most closely related to D, the clade containing C and D is most closely related to E, and the clade containing A and B is most closely related to the clade containing C, D, and E. Cool. Next question. Okay, next question. This is a relatively straightforward one. All I want you to do is tell me the number of tips on this tree, the number of nodes on this tree, and the number of branches on this tree. I'll give you a little bit of time to pause. but let's now jump into it. So what we have here is a very simple phylogeny, but let's start with just the number of tips. Again, just the tips are the ends of the trees. And so here we have 1, 2, 3, 4, 5, and 6 tips. Very easy, just what's at the top of the tree. Cool. Now let's get into the number of nodes. So what I'm going to do is I'm just going to circle every single node on this tree, and we'll just start on this side here. So here we go, A and B, they meet at this node. We know C and D meet at this node. We know E and F meet at this node. We know AB and CD meet at this node. And we see that the clade ABCD meets with the clade E and F at this node right here. And we just need to number these quickly. 1, 2, 3, 4, 5. Awesome. We have 5 nodes on this tree. And now the last one is number of branches. So this one I understand might be a little confusing. So branches, again, are really the vertical components. These horizontal points are really there more for graphical representation. They don't actually have that much meaning. And there's a little tricky one that I think might cause people to have their branches off by 1, so we'll accept 2 answers here. But let's highlight all of the branches. So we have 1 branch here, 1 branch here, 1 branch here, a branch here, here, and here. But we also have the branches going to these clades. So the branch that goes from the clade A and B, the branch coming down from the clade containing C and D, the branch containing E and F, and the branch containing A, B, C, and D. Okay. Now, where it might get confusing is this root node, this root branch. If you counted it, I would completely understand, but the root is not necessarily a branch. At least we don't consider it a branch in many cases. The root is just what's holding the tree all together. There is discussions about rooted versus unrooted phylogenies. We're ignoring that for this video. That'll be sometime in the future. But for now, we're just going to ignore the root as a branch. If you were off by 1, still give yourself the credit, because I did not explain that enough. Okay, but let's just count this out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have 10 branches. So again, we'll give you a little bit credit. We'll give you that bonus credit if we did 11, or if you said 11, because I didn't explain that well. But we have 6 tips, 5 nodes, and 10 branches. This exercise, you very rarely need to count the number of nodes or the number of branches. This is just testing your knowledge of, can you tell what is a tip, what is a node, and what is a branch? Cool. Let's go on to the next question. So this question is going to test your ability to discover what a most recent common ancestor is between 2 groups. Specifically, I want you to find the most recent common ancestor to A and F. Okay? I'll give you a little bit of time to pause. Let's answer this question. So again, the most recent common ancestor is the ancestor to 2 groups. It is where they first meet on a phylogenetic tree. And what node? This is the node they most read. So I realize I didn't label this, the most recent common ancestor, so hopefully you have the node in mind. But let's just work this way down, and I'll show you the method that I used when I was learning. So starting at F, let's just start at F because I want to. We'll go down and we'll go to that first node, okay? Then we'll start at A, and we'll go down to the first node that it runs into. Well, they did not meet up, so let's keep going down step by step. With A, we're going to go down to another node. F will go down to another node, okay? Well, they did not meet up. Now, with F, I'm not going to go down further because we're actually lower on the phylogeny, and we could tell that if we did this, A, go down the phylogeny, we meet up with F. Okay, so this node right here is the most recent common ancestor. If you use this methodology and you went down to F, right, well, you'd realize that there's nowhere left to go. And again, we're looking at the node where they first meet, okay? A and F, this is a common ancestor to F, okay, to A and F. This is a common ancestor, right? Because if we follow the phylogenetic tree, we go up, but it is not the most recent common ancestor, okay? Most recent is the one where they first meet up on the tree. If we're starting at the tips and we're going down, we're going backwards in time, this would be the most recent common ancestor. So if you got this, awesome. You are reading Phylogenies, great. And if you didn't, that's fine. Practice. Start doing this tree with many different groups. Look at the most recent common ancestor of A and E. Look at which is actually the same as the most recent common ancestor as A and F, by the way. But it just gave you the answer. Look at like H and I, A and B. Just keep trying this, or do it with a real phylogeny, and it really helps. But let's move on to the last question for this video. This is going to be a very long video. Last question, and this one is going to take maybe a little bit of time. And the question is, how many monophyletic clades can you make on this tree? Okay, I'm going to pause the video. I want you to try it out yourself. Maybe draw it on a piece of paper, but give yourself some time to pause. So let's start answering this question, and we'll answer it simply. We're just going to start drawing circles around the clades. Okay, we're going to start drawing them where we see them. So here, let's do it in red. So here we have a monophyletic clade around A and B. Okay. We also have a monophyletic clade around A, B, and C. Again, it is including the ancestor and all of its descendants. A and B has this ancestor here. C has this ancestor here. Awesome. Okay, D and E is a clade, monophyletic clade. We can do this. F and G is another monophyletic clade. Again, looking at these ancestors here and all of their descendants. We have another clade that is around D, E, F, and G. Okay, right here, there's another clade, monophyletic clade. Why? Because of this grouping here. And there is one more monophyletic clade. That is the entire tree itself is a monophyletic clade. Okay, this one you might have missed, and that's totally fine. So let's tally these up. We have 1, 2, 3, 4, 5, and 6. We have 6 monophyletic clades. So monophyletic clades. Awesome. So you might have been tempted to draw some lines around, let's say, just G, for example. We did talk a little bit about this during the clade portion of this video. Let's actually make this less confusing. Let me draw that in green. So, for example, if you drew a clade around G, this is one where you could give yourself some points. It depends on the tree itself. With no extra information, this would actually be considered a... See, this is where it gets tricky because it's not really polyphyletic, but it doesn't include the common ancestor. You could argue this is a paraphyletic group. So that's why I specified monophyletic groupings. It doesn't include the common ancestor in all the descendants. But of course, if this tree, if this clade was, say, the birds, like it's a collapsed tree in the example we gave, and then it's split out from further there, then yes, you would consider that its own clade. So if, for example, if we zoomed in on G, and let's just put G down here, yeah, you can see that. And it's split off like this, but we've collapsed it down to make G appear like this, then you could get away with calling that a monophyletic clade. So the correct answer, based purely on what we see on this phylogeny, is 6. But if you knew any extra information, like you knew these were the snakes, and this was the lizards, these were the crocs, and these were the birds, you could make more clades, and then you'd have a clade total of, I think, 11. So like A, B, C, D, E, F, G is 7 plus 6, 11. Okay, but hey, that is everything for this video. So if you liked what you saw, make sure to subscribe. If you're watching till the end, you're awesome. I hope that you really like this educational content. It is a little bit different. I think at some point we'll actually talk about how to make a phylogenetic tree. But hey, like, share, subscribe, do all the things that YouTubers tell you to do, and have a wonderful day.